Morning everyone, how are you? Welcome to my YouTube channel Physician Achal. By the way, if you're just new to this channel, just subscribe to this channel and just hit the like button if you just like my way of teaching. Okay, by doing that, you are gonna give me some kind of encouragement, and with that encouragement, I'm gonna make lots of videos like that. Okay. By the way, this is going to be our part 3 of the lesson Forces and Laws of Motion. Actually, we have mainly discussed in the part 2 video where we have mainly discussed all the concepts regarding this lesson. Okay, and in today's video, we're going to mainly discuss the numerical problems that basically included in your lesson, only the numerical problems, and those numericals are going to be on the basis of the concept that you actually get in this lesson. So just give me your 50 minutes, okay? Use your just 50 minutes and you're going to get some new concepts regarding this lesson, and you're going to get some new experiences too, okay? Just let's start the class. Okay, this is the time to solve our questions, okay? So our first question is actually saying us that a truck starts from rest, okay? One information thing is actually given. A truck starts from rest, rolls down hill, that is the resting is actually given here. You have to be very careful about that. Rolls down a hill with a constant acceleration. Again, constant acceleration is given. Okay, if he travels a distance of 400 meters in 20 seconds, that is distance and time is actually given. Find its acceleration. You have to find out or you have to calculate the acceleration. But before that, some information is actually given. The mass is given. Mass is given in 7 tons. Again, hint is given that 1 ton. 1 ton equal to 1000 kg. So you have to convert the 7 tons into kg. Simple question. First, what do you do? We will just first write it down what is actually given from the question. Okay. Given. Simple question. Don't worry about that. What is actually given? Distance. I will represent the distance by s. Okay. By is equal to 400 meter. Okay. What is the time actually given? Time is given as t equal to how much? 20 seconds. It is also given. And mass m is given as how much? 7 ton. Again, we can convert this 7 ton to kg. That means multiplied by 1000, right? So what is going to be there? 7000 kg. Absolutely got it. We have to calculate force, right? We have to calculate force and what? Acceleration. Okay. Again, one information is given that a truck starts from rest. That means what you can write? U equal to how much? It's going to be 0. Right or wrong? Obviously right. So to calculate the acceleration, we can use one formula, and that formula is nothing but that second equation of motion. We have got the equation of motion in the lesson motion, right? 3 equation of motion we have got. We are going to use the second equation of motion. That second equation of motion is says that S equal to ut plus half of at square. Simple question. Now we will put down the values. S is given as how much? 400. And since u is 0, this whole time is going to be 0 plus half of a. We have to calculate the a. And how much t is given as? 20 seconds. So t square, that means 20 square. If you further solve it, we are going to get 400 into 0 plus something is always 0. That means what we can write? A by 2 into 20 square means how much? 400. Right or wrong? We can cut it down. 400, 400. How much is going to be there? A by 2 equal to 1. So if you further solve, you are going to get A equal to 2 meter per second square. Since it is acceleration, so the unit is going to be A equal to 2 meter per second square. Now we have got the acceleration. Now I have to calculate how what? We have to calculate the force. Hence we know that F equal to how much? ma. And what is m is given as? 7000 into what is the acceleration? 2, and unit is going to be kg meter per second square. If you solve it, you are going to get 7000 into 2 equal to 14,000, and kg meter per second square means Newton. So this is the simple question and simple solution. Okay, so just try to solve it, okay, and just write it down in your copy along with me. And now we will move towards our next question. What this next question is saying that? What this question is saying? A stone of mass 1 kg. We will write it down. Okay. M is given as 1 of kg. Okay. Now what is the second option is given as velocity of, that means 1 kg is thrown with a velocity of 20 meter per second square, right? So we will consider that as a initial velocity. I will explain why we have considered that initial velocity. Okay, 20 meter per second. Across a frozen surface, a lake, and comes to rest. That means what? Final velocity is going to be how much? 0, obviously. That's why it is the initial velocity at 20 meter per second is nothing but the initial velocity. After traveling a distance of 50 meter, that means what is extra information is given actually? That distance, that is nothing but s equal to how much? 50 meter, right? Mass is given, u is given, and distance is given. That means mass, velocity, and distance is given. Now, how do we have to calculate? We have to actually calculate the friction between the stone and ice. So, what we can actually write? We can write, to actually calculate the friction, we need to find out what? Friction is nothing but a force. So, what we can write? We have to calculate the force. We know that force is having a relation F equal to ma. Right or wrong? This is the relation. Okay. So here we have to actually, that acceleration is not given. So we have to calculate the acceleration. So how we will calculate? We are going to use equation of motion. And now we will use, since u and s is given. Okay. So you have to actually think. And here what? P equal to 0. In one important fact, because it is come to rest. Right. So P have got, u have got, and s we have got. So we can use a third equation of motion. That third equation of motion says v square minus u square is equal to twice of as. Right or wrong? Here v is equal to 0, so 0 minus u square is how much? 20 meter per second. So if you put down the values, 20 square into a, we have to find out the a, and s is given as 50. Simple. So minus 400 into equal to 100 a. So what is going to be the acceleration? A equal to how much? Minus 4. Okay, and the unit will be minus 4 meter per second square. Cool. So this is the unit of acceleration, or the value of acceleration. Now we have to calculate the force. So the force will be F equal to ma. Okay, m is given as how much? M is given as 1 kg. So 1 into acceleration is given as minus 4. The unit is going to be kg meter per second square. So 1 into minus 4 equal to minus of 4 kg meter per second square. Minus of 4 Newton. Now, what that this minus sign signifies? The negative sign actually signifies that friction force is going to work, okay, in the opposite direction of our action, right? That's why the negative sign is here. Okay, you just don't need to get confused about that. Okay, this is the main solution of our question number 6 of your NCERT exercise part of your lesson number maybe 9. Okay, forces and laws of motion. Okay, now we will move towards our next question. What this question is actually saying? Okay, here a combination of some mechanical instruments or mechanical vehicles are actually given. Okay, just try to understand what is actually given. It is actually saying that, okay, just wait for a minute. This question is saying 8,000 kg. Okay, this is the mass of an engine. That is a 8,000 kg engine pulls a train of 5 wagons. Okay, each of mass 2,000 kg. Along a horizontal track. That means a relay track is actually given where the engine has a mass of 8,000 kg and its wagons, that is going, it has actually 5 wagons and each of is having 2,000 kg. Okay. Again, what is actually given? If the engine exerts a force of 4,000 Newton, that engine that is actually giving a force to actually move that train, that force is nothing but 4,000 Newton. So it's not 4,000, 40,000 Newton, and the track offers a friction 5,000 Newton. Okay. That train is actually applying a force of 40,000 Newton, and in the backside, on the backward direction, friction is actually work. So that friction force is nothing but 5,000 Newton. So first we will actually write it down. Again, what we have to calculate? We have to calculate the net acceleration force and the acceleration of the train. Okay, we will solve that. Don't worry about that. Okay. First we will write down what is actually given. Okay, before that I will draw one figure. Try to draw one figure. This is the engine, okay, of that train. Okay, these are the wagons. 2, 3, 4, and 5. Consider this is a train linked like that. Okay, this engine is having mass of how much? 8,000 kg. Okay, and all these actually having their mass 22,000 kg each. Okay, they are having mass. So what is the total mass of the train? Okay, we can solve it. You are going to need it. Total mass of the train. Okay, and I will represent that by capital M. Okay, 8,000 plus, okay, 8,000 is the mass of the engine, plus there are 5 wagons and each wagon carries a mass of 2000 kg. So what's the total mass of these 5 wagons? 2000 into 5. So if you solve, you are going to get 18,000 kg, okay, of the total mass of the train. We have got it. Okay, again we have to use it. Keep in mind this value. Okay, 18,000 kg. Now first question I will try to solve. What this first question actually asks? The total or the net accelerating force. That means whenever that train have to accelerate, it have to some accelerating force are there, right? That net accelerating force is going to be net accelerating force is equal to, okay, and I will represent that force as F of A. Okay, that accelerating force. That A means acceleration and F means force. That means the accelerating force. That force will be equal to 40,000 minus 5,000. Okay, Newton. That means whenever that engine have to apply force in this direction, that is nothing but the how much? 40,000. Again, since this force is acting here, there will be one backward force. That backward force is nothing but what? Frictional force, and that force will in this direction is nothing but how much? 5,000 Newton. So the total force that is acting actually will be how much? There minus, okay, so we have just multiplied or so minus it, you are going to get 35,000 Newton. Clear na? Okay, this is the main thing. Now we have to actually find out the acceleration of the train. Okay, now this thing is going to use that mass. Okay, wait, we have got F of A equal to how much? 35,000 Newton. Okay, again we have got the mass of the whole train. Mass of the train that is empty is nothing but 18,000 kg. We need to find out what? Acceleration. Simple relation is there. We know that F of A is going to be mt into A. This is nothing but F of equal to ma. We are just using this relation. Okay. Now we have got F of A is how much? 35,000 and m of t is how much? 18,000 and A. We need to find out the A. So we will write down A equal to 35,000 by 18,000. Okay. So you are going to get the answer as 35 by 18. 35 by 18, and it is equal to 1.944, okay, meter per second square. Okay, net accelerating force that actually acting whenever that train has to move forward by applying a force of 40,000 Newton. When that train actually applied a force of 40,000 Newton, a backward force is also acting. That is nothing but a frictional force, and that is acting in the opposite direction of the force of that given by train. So we have to actually minus it. Okay, so that force is nothing but 35,000 Newton. Again, once we actually get that accelerating force, using that accelerating force, we can actually calculate the acceleration using that total mass of the train. Now we will actually move towards our next question. This question is actually saying that, okay, this question is saying something. What this question is actually saying, we will actually check it. Okay, an automobile vehicle has a mass. That means first we will write it down. M is given as how much? 1500 of kg. Okay, this information is given, and what must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration? That means what we can say, that V is going to be 0. It have to be stopped, right? And that acceleration is given how much? 1.7 meter per second square. But the thing is, there is negative acceleration, so we have to put a negative sign. Simple. So we have got the mass of the vehicle as 1500 kg, and velocity, that final velocity is going to be 0. You have to acceleration, we have to find out the force. Simple relation. Mass is given, acceleration is given. Use the relation of force, that is F is nothing but, okay. By the way, one thing is you have to be clear about that. What is actually saying that what must be the force between vehicle and the road? What can be that force? That force is nothing but what? Friction. So I will represent this force as F of F. That means that small suffix F means friction, and this is the MA. What is M is given as 1500 into minus 1.7. That means kg meter per second square. If you solve this, you are going to get how much? Minus of 2550 kg meter per second square. If you solve this, you are going to get minus 2550 Newton. Simple. Now, what that negative sign is actually sign? That negative sign is, write down that negative sign, okay, actually depicting that the friction is acting in opposite direction. Okay, but if you consider the magnitude, you are going to write like that. F of F is equal to 2550 Newton. Simple question it is, right? Now we will actually move towards our next question. Okay, this is our next question. What this question is saying that using horizontal force of 200 Newton, okay, information is given. Okay, using a horizontal force of 200 Newton, that means we will actually represent it by F of H. F of H means horizontal force is given as 200 Newton. Okay, so then it is saying that we intend to move a wooden cabinet. Okay, that means wooden table, we can consider wooden table, wooden box, anything we can consider that, across a floor at a constant velocity. That means if it is a wooden box, okay, we have actually intended to move that object in this direction by applying a force of how much? 200 Newton, right, at a constant velocity. What is the friction force that will be exerted on the cabinet? Okay, now we have to check that what is going to be the force that is going to be in that direction exerted by the wooden box or wooden cabinet when we are going to apply that force of amount 200 Newton, right? But to understand this concept, okay, we have to actually consider the concept of third law of motion. What third law of motion actually says? Third law of motion actually says that whenever we actually apply a force, okay, if this is an object, okay, if we apply certain amount of force in this direction, that object is going to apply same amount of force, a similar magnitude force but having different direction. Okay, if we consider this as a positive direction, this direction is going to be what? Negative direction. Okay, so that force F1 is going to be equal to F2 but having a direction of different direction or opposite direction. That's why there is going to be a negative sign. Right or wrong? Obviously right, right? So we are going to use that concept. So this is nothing but a theoretical concept or conceptual question. You don't need to solve anything. We can actually answer this question by our concept. Okay, so what is the frictional force? That means what you can say, we have got from our third law of motion that the two forces are going to be equal but having some different direction. That's why there is a negative sign. So that frictional force, okay, is going to apply a force of how much? Obviously 200 Newton. Right or wrong? Okay, since we are not actually applied that force, we have some intention, right? So that force will be equal to this much. Okay, you may think that here is written that constant velocity is given, right? You may think that since it is given as constant velocity, so if that object have to move in constant velocity, this backward force should have some less value compared to this force, right? Then that object will move. Now, if this force and this force become equal, that means if this force become equal to this force, what is going to happen? That product will not move. It will be at rest because that force acting from both the sides is equal, right? So this is not going to move. But you just look in the question very carefully, okay? It is saying that we intend to move. That means we have an intention, okay, to move that object by applying a force of 200 Newton. Okay, when we will going to have an intention to apply a force of something, that means consider that if I am having intention to move a book with a force of how much? Consider 10 Newton. Okay, that means I am not applied the force yet. I have just an intention. Okay, so with that intention, what is going to be the force that is going to be given by that book? It is obviously going to be 10 Newton, but it is in the opposite direction. Similar condition is also here. That frictional force is going to have a magnitude of 200 Newton. That means I am considering a magnitude here. Okay, so frictional force is going to have a same amount of force that is actually given by that us or some extra object that is applying in a horizontal direction. Okay, that means what you can write, F of H is equal to F of F. That means horizontal force is equal to the frictional force. That means equal to nothing but 200 Newton. Simple question, simple answer. Now we'll move towards our next question. But by the way, I have considered you have actually understood the concept of this question. Nothing to be get complicated. We just have to simply use that third law of motion. If you know the concept of third law of motion, you have just understood this question. Now we'll move towards our next question. Okay. This question is actually saying that two objects are actually given here, each of mass having 1.5 of kg. Okay, and are moving in the same straight line but in opposite direction. I will consider that diagram. Okay, this is one object M1. Okay, this is one more object M2. Okay, they having same mass, that means nothing but 1.5 of kg and 1.5 of kg. Okay, 1.5 kg. What the information is given that they are actually moving in a same straight line, okay, or straight path, but in opposite direction. If that M2 is moving in this direction, M1 moving this direction. Okay, and what is the information given that the velocity, okay, of each object is 2.5 meter per second. It is having a velocity of how much? 2.5 meter per second, and it is also having velocity 2.5 meter per second. Okay, now, okay, what we have to calculate that the velocity of each object is given before the collision during which they stick together. Okay, okay, what will be the velocity of the combined object after collision? That means since they are actually now moving in the opposite direction, but before they moving in the opposite direction, they were stick right now. Okay, so if they both the two objects are moving in opposite direction, that means what? Since they are moving in opposite direction, there is no possibility that they are going to actually in collision, okay, or they are going to have collision. But this is possible that before they moving in the opposite direction, they have some collision. Okay, after that they are just moving in opposite direction. Simple concept. This is actually saying that. Now they are actually asking that what will be the velocity of the combined object after collision. That means they are asking that when the two bodies get collided, what is going to be the actually velocity of the combined object? See, without solving this question, actually simply we can say this question answer. Simple conceptual question. What is actually asking that what will be the velocity of the combined object? Okay, consider that maybe before they moving in the opposite direction, they are maybe here. Okay, they are maybe here. Okay, where they actually get collided, M1, M2. Okay, once they got collided. Okay, right now we can say when they get collided, they are at rest now. But after certain at that time of collision, they are at rest. That means what you can say, the combined object is moving with a velocity of 0. Okay, I will solve that. You are going to get this. Okay, first we have to write down what is actually given. That mass is given as how much? 1.5 kg. Okay, V1. Okay, I will write down M1 V1. V1 is given as how much? 2.5 kg. Sorry, not 2.5 kg. Sorry, 2.5 meter per second. Okay, so what is going to be the M1 V1? That is momentum is nothing but 1.5 into 2.5 kg meter per second, right? And what is the M2? M2 is given as similar mass 1.5 of kg. And what is the V2? See, if I have considered the V1 as 2.5 meter per second, V2 is going to be also 2.5 meter per second, but one thing will be different, that is a sign. Since it is moving in the opposite direction and velocity is nothing but vector quantity, so there is going to be what? Basically a negative sign. So again, what we can write from the conservation formula? That total momentum before collision, total momentum before collision is equal to total momentum what? After collision, right now? After collision, right? So now I have to put the values. total momentum before collision is nothing but m1 v1 plus m2 v2. But what is actually given that after collision they are going to move, okay, as a one object. That means they are going to have a combined object. That means m1 plus m2, if they move with a combined object, what is going to be their velocity? Their velocity is going to be the same. That means it is represented by v. Okay, we have to calculate the v. Okay, so we will actually use that formula. We have got that m1 v1 plus m2 v2 is equal to m1 plus m2 into v. Okay, now we will put the values. m1 value is nothing but 1.5 into v1 is 2.5 plus m2 is having value 1.5 and v2 is having value minus of 2.5. Simple. Again here 1.5 plus 1.5 into v. Okay, now if you look closely, if you further solve it, we are going to get 2.5 plus into minus is going to be minus 1.5 into 2.5. Again we are going to get 3p. That means you have to not 3 volt, 3 into p. Okay, but look here, this is positive, this is negative. If you write down 0 here into 3 into v, if the value of the v will be 0 meter per second. So what we have got? But total momentum or the combined object going to move with a velocity 0 after they collided. Simply I have got that. That means after collision they are going to be at rest. That means, right? This is a fact. Simple question. Now we'll move to our next question. Okay, what this question is actually saying that a hockey ball, right? A hockey ball of mass 200 gram. That means we should write down mass m equal to how much? 200 gram. Okay. Again, it is given in as CGS unit. You have to convert to SI unit. That means in kg. It's going to be 0.2 of kg, right? Again, having a velocity 10 meter per second square is struck by a hockey stick so as to return it along the original path with a velocity of 5 meter per second. Okay, that means a hockey ball is actually moving at a speed of 10 meter per second. This means it is nothing but the, if you can write the initial velocity, that is nothing but the, we'll write it down by v1. It is nothing but the 10 meter per second, right? Simple thing. Again, that hockey stick actually hit that ball, okay, to move in the original direction, okay, from which direction it is actually coming, with a speed of or with a velocity of how much? v2 is given as 5 meter per second, right? So this is the main fact. Now what we have to actually calculate the magnitude of the change of momentum, okay, in the motion occurred in the motion of the hockey ball hit by the applied by the force, right? That means same ball having two different velocities, right? So that means what we are going to get two different momentums. So P1 is going to be how much? MP1. It is going to be 0.2 into, okay, 10 kg meter per second. By the way, one thing is actually I absolutely forgot to tell that return. That what return is meaning. That means when the hockey stick hit that ball moves in the opposite direction towards its original direction. That means that v2 is going to be nothing but what? There is going to be a negative sign because it moves in the opposite direction. Okay. If that ball first coming in this direction, once it hit by the hockey stick, it moves in this direction. That means if it is a positive direction, this is going to be negative direction. So that v2 is going to be negative, right? So if we solve that, we are going to get 2 kg meter per second. Now what about that P2? That means second momentum is nothing but m v2. What is m is given as 0.2, same. Okay, and what is the v2 is actually given as minus 5 into kg meter per second. So it is going to have a value of minus 1 kg meter per second, right? Now we have to calculate actually the change in momentum. Just change in momentum. Change in momentum will be P1 minus P2, right? P1 is given as 2, right or wrong? Minus 1, okay, into kg meter per second. If you solve this, you are going to get 2 minus plus 3 kg meter per second. Okay. we have got this change in momentum as P1 minus P2, that is nothing but the 3 kg meter per second. Simple question, simple answer. Right? Now we'll move towards our next question. Okay. What this question is actually saying that a bullet of mass 10 gram. Okay. Along with that, we will write it down what is actually given. Always, whenever you study a question, okay, read a question, you always do one thing. You just write down the values you just going to get while just reading that question. We have got that mass of the bullet. We'll represent it by the MB is nothing but how much? 10 gram. Okay. Since in CGS we have to convert it to SI, that is nothing but the 2 kg. So it is going to be how much? 0.01 obviously kg. Right? Again, what is actually one more important thing is given that it is have a velocity, right? That is nothing but how much? We will represent it by U. That is nothing but 150 meter per second. Now you may think why I only have written by U. You understand that? Because what it is having that horizontally that bullet will move horizontally with a velocity of 150 meter per second and strikes a stationary wooden block and comes to rest. If that comes to rest, what is going to be the final velocity? Final velocity is going to be nothing but 0. Okay, and time is given. What is the time? T equal to 0.03 second. Okay, so now we have to actually find out that calculate the distance of penetration of the bullet into that block. Just consider it. Okay, if it is the wooden block, okay, this is a wooden block. Okay, first the bullet comes like that. Okay, it moved, then it just entered that wooden block. Okay, so now you have to actually calculate how much it actually penetrates that wooden block. Okay, that means what we have to find out the what? Distance. Okay, again, also calculate the magnitude of the force exerted by the wooden block. Remember, we have to calculate only the magnitude, not the direction. That means no negative sign should be there because we have to only calculate the magnitude, right? That means you have to calculate the force. Okay, first we will try to solve the actually distance. Okay, how we will solve the distance part? Simply, we have got V, we have got U. Okay, but before that, what will you do? We'll calculate the acceleration. We are going to need that acceleration to calculate that distance. Remember that. Okay, acceleration A is having formula A equal to V minus U by T. Okay, V is having a value 0, U is having value 150, okay, and T is having value 0.03, and it will be meter per second square, right now. So now, if you solve this, you are going to get minus 150 by 0.03 meter per second square. If you further solve it, you are going to get minus 5,000 meter per second square. This is what? This is nothing but the acceleration. Okay, now we will try to find out the distance. We got that V square minus U square is nothing but twice of AS. This is nothing but the third equation of motion. Here V is 0, so U is going to have a value minus U square is equal to twice of AS, right? So if you find the values, minus you have got the U value as 150, 150 square is nothing but 22500. And what about the acceleration? 2 into minus of 5,000 into S. Okay, then minus sign will get cancelled out. You are going to get S equal to 22500 by 10,000, okay, meter. If you solve this, you are going to get 2.25 meter. We have got acceleration here. Again, we have got S here. We are going to both use these two things, and then we will try to find out what? The force. And what is that force will be? That force is going to be F equal to what? MA. Okay. What is M is given as? 0.01 kg. And what is the acceleration? Acceleration is nothing but minus of 5. By the way, we will not consider minus because we have only going to consider the magnitude. So we will write down this positive 5,000 meter per second square. if we are going to solve, we are going to get 50, okay, 50 kg meter per second square. That means nothing but 50 Newton. Okay, this is the solvation or the solution of this 14 number question. Okay, simple. All first we have to write down all the things, okay, that is actually given in the question. Just write it down. If it is in CGS unit, just convert it to SI unit. Okay, just have to read that question very carefully because it is written as the comes to raise. That means velocity time, final velocity that V is going to be 0. That's why, or you can write it down V1 or V2. You can also write like that. But if you write the initial velocity as U, it is going to be a little bit convenient for you. Okay, so just write it down U equal to 150 meter per second. Okay, after that V we are going to get. So just use that relation of acceleration, you are going to get the acceleration. Okay, since the time is T is given, and using that value of acceleration, you can calculate the rest. This is nothing but the what? Distance s equal to 2.25 meter, right? And again, using that formula of acceleration or using that value of acceleration, you can still calculate that mass, or using that mass, you are going to calculate the force. Simple fact, right? And force you have got as nothing but 50 Newton. We have got the acceleration as minus of 5000 meter per second square. Again, we have got the distance as nothing but 2.25 meter. We have solved this question. Simple question. Now we're going to move our next question. What this question is saying? This is a 50 number question. An object of mass 1 kg. Okay, we have got one mass traveling in a straight line with a velocity of 10 meter per second. Collides with and sticks to a stationary wooden block of mass 5 kg. That means you have got two masses. Okay, then they both move off together in a same straight line. Okay, calculate the total momentum just before the impact and just after the impact, and also calculate the velocity of the combined object. Okay, first we will write down what is usually given. Okay, masses are given, so write down m1 is nothing but 1 kg. Okay, and m2 is given as how much? 5 kg. Okay, and v1 is given as how much? 10 meter per second, right? So what is going to be the value of the v2? Look carefully. What is actually given? Stationary wooden. That means it is in stationary motion. That means v2 is going to be 0. Okay, so what is going to be the total momentum before collision? Total momentum before collision, okay, is going to be m1 v1 plus m2 v2. Okay, write down the values of the m1 is nothing but 1, value of v1 is nothing but 10 meter per second, and this whole term is going to be 0 because v2 is 0. So we write down v0. So we are going to get 10 meter per second, right now. And what we have to calculate that just after the impact. That means we have to calculate total momentum just after the impact. That means what? Total momentum after collision. Since momentum conservation law gives us that total momentum before collision and total momentum after collision always remains constant. Right? So just after collision. Okay, by the way, this is not should be the into kg. That means we are going to get 10 kg meter per second since it is momentum P1. Okay, just after collision, P2 is going to be same 10 kg meter per second, right? Now we have to calculate that. We also calculate that the velocity of the combined object. Okay, after they get collided, okay, we have to calculate that. Okay, right? After collision, before collision, right? So what we can write? m1 v1 plus m2 v2, m1 plus m2 v. Why I only written v? Because they have collided and they move with a combination of mass. If they are combination of masses, they will move at a single velocity. So we will write down small v. So just write down the values that m2 v2 will be 0 because since v2 is 0, so there will be only m1 v1. m1 is given as 1 and v1 is given as 10 equal to, and it is going to be 2v. Okay, right or wrong? No, sorry, not 2v. Sorry, it is going to be how much? 1 plus 5. Okay, m2 is having a value of 5. So this is nothing but 10. This is nothing but 6 into v. we have to find out the V. It is going to be 10 by 6 meter per second. If you solve it, you are going to get how much? 1.67 meter per second, right? This is the answer of this question. Now we will move towards our next question, right? That question is given this one. Okay, what this question is actually saying? This question is actually saying that an object of mass, again the mass is given, write down the mass. Again, look at the question, only one mass is given, so we will only write down small m, 100 kg. Okay, done. Again, two velocities are given, so is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. So we will write down the velocities as like P1. Okay, 5 meter per second. And what is the velocity 2? That is the second velocity is given as 8 meter per second. Okay, simple. Now what is the time? T is given as 6 seconds, right? So calculate the initial and final momentum of the object and also find the magnitude of the force exerted on the object. We have to simply find out the initial momentum, that is if V1 is the initial velocity and V2 is the final velocity. So for the initial velocity, there is going to be an initial momentum, and but that for final velocity, we are going to get final momentum. So we will represent that final momentum as P1. P1 is going to be nothing but mv1. Just solve it. 100 into V1. V1 is given as 5. Is nothing but kg meter per second. That is nothing but 500 kg what? Meter per second. Now what is the second or final momentum? mv2. That is nothing but 100 into what? Second momentum velocity is given as 8. Okay. So it is going to be kg meter per second. So it is nothing but 800 kg meter per second. So we have got the total momentum or two momentums. It is nothing but initial momentum and final momentum. Now we have to actually calculate the magnitude of the force exerted on the object. So how will calculate? We will actually use that rate of change of momentum is nothing but what? Force, and that formula is given by F equal to m into V1 minus V2. Okay, not V2 minus V1. We will not V1, we will write V2 minus V1 by T. Okay, final velocity minus initial velocity. M is given as 100 into what is that final velocity? 8. What is the initial velocity? 5. Okay, by what's the time? 6 seconds. That means 100 into 3 by 6. Okay, if you solve this 3, 1, 3, 2, 2, 2, 50. That means 50 Newton. Simple answer. We have got two answers. That is the initial velocity, sorry, not initial velocity, initial momentum, final momentum, and the required amount of force we have actually calculated. Now we will move towards our next question. Okay, this is your last question from your exercise part. Okay, that's numerical problem actually. Not only that, I have actually left some actually theoretical question answer there. This is only because of your numerical problems I'm just making this video. So because numerical problems having more marks, right? So again, that conceptual questions can be actually done by yourself. But I thought that this kind of numerical problems have give you some kind of difficulty in actually solving. That's why I thought that I should actually make a video in solving these kind of questions. Okay, so this is our last question of this exercise part. So what this actually question is actually saying that how much momentum, okay, will a dumbbell of mass, dumbbell means what? With which we used to do in gym, right? That is a dumbbell of mass 10 kg. That means what? That mass is actually given as how much? 10 kg. Transfer to floor if it falls from a height of 80 centimeter. Okay, take this downward acceleration is going to be 10 meter per second. Okay, always remember that downward acceleration is also known as a gravitational acceleration, and it is always represented by what? G. It is given as 10 meter per second square. By the way, one thing you should always know that actual value of G is nothing but 9.8 meter per second square. But here only they have taken the approximation for the convenience. Okay, you may ask me that why I have only considered 10, because if you round figure it, you are going to get 10. Okay, simple concept. So Height is given, and we'll consider that height is nothing but as h 80 centimeter. And since it is in CGS unit, we have to convert to SI unit. It is nothing going to be 0.8 meter, right now. So again, what is the given? Mass is given. Mass is nothing but what? 10 of kg. We have to actually calculate the downward, sorry, not downward, we have to calculate the momentum. But before that, okay, what is going to be the initial mass velocity? When a ball actually drops from here to the ground, okay, this is the initial, okay, and this is the final, okay. Always remember, whenever that ball have to go to the ground, in that case, U is going to be 0. But here, when that ball reaches to the ground, at that moment, it attains a velocity, some velocity, right? So that final velocity is going to be V. So what we will write? We will write that U is equal to 0 and final velocity Vf is nothing but equal to V. Okay. So we will use that formula. Okay. But before that, to calculate that actually momentum, we have to calculate that amount of V, right? So we will use the that third equation of motion is nothing but V square. We will write down Vf equal to minus U square equal to twice of ZH. That means we have actually substituted the value of A by Z and S by H. They are all similar. Okay, and here U is equal to 0. So what is going to be Vf? Vf means nothing but V square is nothing equal to 2 into 10. Okay, into H is, or the height is given as 0.8. Okay, so we are going to get a value of V square is equal to 16. So what is going to be V? V is nothing but 4 meter per second. We have got the momentum. Now we have to calculate the momentum because we have got velocity. So that momentum P is going to be what? mv. M is given as how much? 10 kg and momentum is nothing but 4 kg meter per second, right? So you are going to get 40 kg meter per second. Okay, this is the solution of this question. Okay, just don't get confused here. Okay, this is similar to twice AS. Here acceleration is this A is actually represented when we actually consider the horizontal acceleration. Okay, and whenever we have to calculate this kind of vertical acceleration, we always have to represent that acceleration by Z. Okay, whenever we actually consider the vertical acceleration, we always consider the distance by height. So this is nothing but a substitution. Rest of the concepts are almost same. Okay, this is the main solution of this question. We have just using this relation. We have to find out the V. Again, that we use that velocity in calculating that momentum. Simple, P equal to mv. M is actually given 10 kg and V is we have got that 4 meter per second. Just solve it. You are going to get 40 kg meter per second. We have just solve it. Okay. But what do you think? Should I give some kind of actually quiz question today? I will give a quiz question. By the way, this is our today's quiz question. This quiz question is actually saying that a bullet of mass A, okay, a bullet of mass A and velocity B is fired into a wooden block, okay, fired into a wooden block of mass C, okay. That means we have got a combination of a system, okay. If the bullet gets embedded in the wooden block, embedded means it just get entered that wooden block, okay. Then the magnitude of the velocity of the whole system just after collision will be how much? Okay, that means you have to calculate the magnitude of the velocity of the whole system after collision. That means what we are going to get, simply I am just giving a hint. You have to just use the concept of conservation of momentum. Okay, then using that hint, try it by yourself and answer me in my comment section. Okay, as soon as it is possible. Actually, moving towards our main physics part, right? That means what we have now mainly deal with some hard concept. Okay, then you will be able to actually crack those higher secondary physics, right? That means we have to prepare by now, okay, or prepare from now. So just try it by yourself. Yeah, this is kind of looking like that. This is kind of difficult question, but it is not difficult question. You just have to clear your concept first. Okay, before that, I'm going to tell you again. Just before that, watch my 2 videos regarding that force and laws of motion. After that, try to solve this question. If you don't do that, you are not going to be able to solve this question. Just believe me that. So just before that, you just watch that 2 videos again and again. Okay. So just clear your concept regarding that momentum conservation thing. Then after that, try to solve this question and then you will be able to do this problem. Okay. So this is the it. and try to solve this question. Again, we will meet in the next video. Till then, stay safe, stay healthy, right? And keep your study full on, okay? Don't skip any study, okay? Or never skip anything, okay? If you have just planned to do something or plan to study something by today, just complete it by today, okay? Don't leave it for another day, okay? So this is the main thing, and we'll meet you in the next video. Till then, stay safe. Bye bye.